Okay, so here we go again. I'm going to start with implicit differentiation, and the word problems for implicit differentiation are the related rate problems, which are pretty hard. I believe they're the hardest word problems from Calculus 1. So the first thing you need to know about implicit differentiation is that it's pretty much the same as regular differentiation. So let's go over a few basics. When you're doing regular differentiation, whenever you have a function f of x, there's many different ways they can ask for a derivative, such as find f prime of x. Or if you have a function y equals something, they can say dy dx. Or I am going to use shorthand notation just because I don't have the Apple Pen yet, so I'm using my finger, so I'm limited with space. So instead of dy dx, I'm going to use y prime. Okay. However, in your book, you're going to notice that they use dy dx instead of y prime all the way down. So what does dy dx mean? It means find the derivative of y with respect to x. So the variable on the bottom, if this were the function, the variable on the bottom needs to match the variable you are dividing. And the variable on top pretty much is the function you're talking about. So in this case, it's going to match. So all you have to do is derive, like bring down the exponent and subtract 1. And that would be your answer. However, when the variables do not match, you're going to be, in the past you've done it, but you've used the chain rule. If you have the derivative of y with respect to x of a function that has, and that you used u, in u being a function that has x inside of it, such as, and you did find the derivative of y with respect to x equals the derivative of u times, you derived u, and then you did the derivative of the inside part, so you did the derivative of u. I remember the notation. I'll show you with an example now. When you use the chain rule, you did y equals 3x squared plus 1 to the third power. And then you said, oh, okay, I'm going to use the derivative of the outside part, assuming this is u. So it's 3, lo de adentro queda igual, so the inside part remains the same. Sorry. And then you multiply times the derivative of the inside part. And that was the chain rule. That's pretty much what we're going to be doing today, except we're not going to work it out. We're just going to write y prime wherever you have to find the derivative of the other part, or the inside part. Okay, so let me show you with examples. This is something so much easier to visualize when you actually see it being done. Some are very easy. You probably already know how to do these, but I'm going to start from the basis because I don't know where you're at with implicit differentiation. So for example 1a, it reads down here, find the derivative, this is another notation, find the derivative with respect to x of x cubed. And in this case, it's really easy because you notice that the variable you're deriving matches with the variable being given to you. So all you have to do is derive. That's just 3. Bring down the exponent and subtract 1. And that would be it for A. Now for B, find the derivative with respect to x. Once again, but your function does not have variable x, it has variable y. So when the variables don't match, this is when we're going to be doing equivalent to the chain rule. So you do the same thing, bring down the exponent, subtract 1, but then you have to multiply times the derivative of y, of the variable that doesn't match. So instead of, in the book they use dy dx, I'm going to be using y prime for a shorthand notation. Okay, now C. Find the derivative with respect to x of x plus 3y. Okay, so here it's a polynomial function, so you just take terms, doing one term at a time. The derivative with respect to x of x is just 1. The derivative with respect to x of 3y, well, the derivative of 3y is 3, but since it's not the same variable, we need to put y right next to it. And finally, letter D is the hard example. And the reason why is because we're going to be using the product rule. So before I get started with the last example in this, letter D in this example, let me go over the product rule. In the product rule is whenever you had two functions multiplied times each other. I used f and s for first and second. So the product rule told you that if you wanted to find the derivative of that, you did the first times the derivative of the second plus the second times the derivative of the first. And that's what we're going to be doing when we have an example such as D. Let me show you why. Find the derivative with respect to x of xy squared, because you have in the same term both variables. So that's when you're going to be using the product rule. So how do you do this? Go ahead and off to the side, find the derivative of each part. The derivative of x with respect to x is just 1. The derivative of y squared with respect to x is 2y, but since it doesn't match, y prime. Okay, so now the first times the derivative of the second, so that's x times 2y, y prime, plus the second times the derivative of the first. And then you just have to simplify that as 2xy, y prime plus y squared. And that would be your answer right there. Okay, so those are very easy examples of implicit differentiation. Let's start working our way up. Example 2 is different because it's an equation now. So now they actually want you to do the exact same thing we just did, but they want you to find dy dx by using regular algebra rules. Find dy dx given that equation. So let's go one by one. It's y cubed y cubed plus y squared minus 5y minus x squared minus x squared equals -4. Okay, so now you take turns, term by term. So the first one, the derivative of y cubed, bring down the 3, subtract 1. And since it's y, you have to put y prime. The second one, bring down the 2, subtract 1. And since it's y, you have to put y prime. The third one, the derivative of -5y is -5, but since you derive y prime. Now the last term on that side is -x squared. The derivative of -x squared is -2x. And you don't have to do y prime because you derived x. This one's easy because there's no term that has both variables, and on the right side, the derivative of any constant will always be 0. The next step is on the left side to group all the terms that have y prime, and anything that doesn't have y prime, take it over to the right side. 3y squared y prime plus 2y y prime minus 5y prime. And then when you're done grouping them on one side of the equation, you're going to take out that y prime as a greatest common factor. Why did we do that? So we did write it out as a greatest common factor, like the opposite of the distributive property, so that we can now isolate for y prime by taking all that, dividing over to the other side. So that's your basic, easy. I'm still not at a difficulty level that I would expect in your AP exam. Okay. This set of problems, I believe, are not something you're going to be finding maybe in your AP exam. Let me go over them very quickly. However, you are expected to know some of these basics. You should know that the equation of a circle, the basic equation of a circle would be x minus h squared plus y minus k squared equals r squared. So, you know the center of the circle is h, comma k, and the radius of the circle would be r. So for A, you have a circle with a radius of 0. A circle with a radius of 0 is pretty much a point. A point is not differentiable. So in this specific example, they ask you, if possible, represent y as a differentiable function, and it is not. For B, it's a circle with a radius of 1. And it's not differentiable because, so pretty much what they did is, first of all, it's not a function because you can touch 2 points, so you have to separate into the top part and the bottom part. So they do that, but then they tell you, hold on, at the very beginning and at the very end, it's not differentiable because it has vertical tangent lines. The last example is a parabola. So it's x equals 1 minus y squared. So it's a parabola that opens to the left. So in this case, once again, it's not a function because it would touch 2 points at the same time. So you would have to break it up into the top half and the bottom half. But then they say, oh, even still, it's not differentiable at some points because over here it has a vertical tangent line. So that's all they say, that at those specific points, the slope is undefined because it has a vertical tangent line. I don't expect that to be in your exam. Let's do example 4. Determine the slope of the tangent line. So whenever they want you to find the slope of a tangent line at a specific point, all you have to do is find the derivative and then plug in the point. So let's do this one very quickly. And you have x squared plus 4y squared equals 4. So they want you to find the derivative. And since you notice that no variable is alone, you have to use implicit differentiation. So let's do the first term with respect to x. How do I know that it is with respect to x? It's always, whenever they want the slope, it's always, remember the formula for slope is change in y over change in x. That's where dy dx comes from. D is change, so it's change in y over change in x. So it's 2x plus 8y, and since I'm deriving y here, y prime equals, and the derivative of 4 is 0. Now I need to isolate for y prime. This term goes over to the other side. Divided by 8y, and then you simplify that. So that's negative x over 4y. So that's your general formula, which is the same we did at the very top. The difference in this problem is that they're giving us a specific point. So you plug in x and y, and go ahead in your calculator and solve for, and you should get 1/2. Now here, it says, find the slope of the tangent line. So once it's the exact same thing, they're giving it to me. So they use the chain rule inside of implicit differentiation. I am going to use a different approach that I would consider easier in this problem. You want to try both of them out. I think this would be easier for this specific problem, when possible. And it reads, find the slope of the tangent line to the graph of 3 x squared plus y squared squared. This is a long problem. Equals 100xy. Okay, so there, and they give me a specific point, 3, 1. Okay, so the first thing I would do when possible is I would expand this to try to get it into a polynomial, like a different term polynomial. So I would FOIL that, and that would give me x to the 4 plus 2x squared y squared plus y to the 4. And then I would distribute the 3. 3x4 plus 6x2 y2 plus y to the 4. And on the other side, I would have 100xy. And then I would take terms, deriving one by one. Let me make this bigger, maybe. Okay, so for the first term, I have 12x to the 3 For the second term, I have to use a chain rule. So it's the first times the derivative of the second, y prime, plus the second times the derivative of the first. So that would be 12x y squared plus, and then here, I need to get rid of that. I would get 4y cubed, y primed. And then over here, I also have to use the chain rule. That's 100x y prime plus 100 y. Now everything that has y prime over to the left side of the equation and everything that doesn't have y prime, let's take it over to the right side of the equation. So it would be, let me simplify that, that would be 12x squared y prime plus 4y cubed y prime minus 100x y prime. A white box. Oh, took the whole thing off. Okay, let me finish up with that. I need more space. The point was 3, 1. Okay, so now that would be equal to anything that doesn't have y prime would take over to the right side of the equation, so it'd be negative 12x cubed minus 12xy squared plus 100y. So now let's take y prime out as a greatest common factor. And then you take that parentheses dividing over to the other side. So I don't want to spend a lot of time in the algebra here. So y prime, you copy that down. And then you substitute the values in the point. Go ahead and do that. And you should get the answer, which was, oh, I don't know. You can go back in the video. I can post the answer later. I missed that. I lost that image. I don't want to do this again. ¿O será que puedo? Lo tengo acá. Yes, your answer should be 13 over 9. And it is a big mess. Both ways you do it, either way, this problem is very messy. So make sure you get 13 over 9 when you do that. I did it yesterday in my first video, and I did get 13 over 9, but it took a while. And I don't want to make them that long. Okay, next. Now, this is where it starts getting complicated. This is the kind of problem that I would expect to possibly see in one of your AP exams, when they want you to find the second derivative implicitly. And the reason why is the following. We have a circle, x squared plus y squared equals 25. So remember, circles are not always differentiable, but they are differentiable at every other point except where there is a vertical tangent. So they're specifying a point, so we're good to go. Negative 3, 4. They don't want the first derivative, they want the second derivative. So obviously you first find the first derivative. So let's go ahead. We have the derivative of x squared is just 2x. The derivative of y squared would be 2y, y prime. And the derivative of 25 is 0. Now I solve for y prime. Make that 2y, y prime equals negative 2x divided by 2y, and you simplify that. So you get y prime equals negative x over y. That's my first derivative. However, they don't want me to find my first derivative. They want me to find my second derivative. So I'm going to work off my first derivative to find the second derivative. You notice it's a division. You're going to be using the quotient rule. So let's go off to the side to practice the quotient, or remember what the formula for the quotient rule is. So in the quotient rule, you have a top and a bottom. And it is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So let's do this for this. So let's go off and find the derivative of the top, which is just negative 1, and the derivative of the bottom, which is 1y prime, because it's y we're deriving. So it's the bottom, which is y, times the derivative of the top, which is negative 1, minus the top, which is negative x, times the derivative of the bottom, which is 1y prime, over the bottom squared. Okay, so that's my second derivative, but let me go ahead and simplify it. I get negative y plus xy prime over y squared. And there's a problem that this would be my second derivative, or they call it this, d squared y over dx squared. I'm using y double prime for shorthand notation. Okay, so what's the issue here? I cannot have y prime as part of my answer. So I need to take this part over here where it's y prime and substitute it for my already simplified y prime equation. So my double derivative is actually going to be negative y plus x, negative x over y squared. And then you have to simplify that equation. And that would give you negative y minus x squared over y squared. And to simplify all of this, I would multiply top and bottom times y. Negative y squared minus x squared over y cubed. And then, however, that's the general formula, but they gave us a specific point for this example, negative 3, 4. So you take that negative 3, 4, and you substitute it in your general formula. Here, go ahead and do that, pause the video, and make sure you're getting negative 25 over 64, which I'm pretty sure you're going to get. And that's going to be the derivative of that, the second derivative of that function. So for second derivative, first you find the first derivative of that, you find the second derivative, and wherever you left y prime, you would substitute your first derivative. So this is the answer for, whenever you write your answer, you have to say d squared y over dx squared equals, and whatever answer you get. Okay, let me erase this because we're going to need the space for the next problem. Okay, let's look at example. Example 8. Example 8, they don't ask you to find the slope. They ask you to find the actual tangent line. So that means first find the slope and then use one of the formulas to write the line to figure out. But all you need is a slope and a point, so you have everything. It's just a lot of math. Okay, find the tangent line to the graph given by x squared plus y squared equals y squared. Okay, so the first thing you would do here is use the distributive property. And then you would use implicit differentiation. The derivative of x to the 4 is 4x cubed. this, you would have to use the product rule. So first, the first one times the derivative of the second one. So it's x squared. Let me bring the 2 in the front. Y prime. Plus the second times the derivative of the first equals. And on the right side, I'm going to have aquí también. Voy a bajarme. 2y prime. Okay. So now everything that has y prime over the left side y lo que no para el right side, y me queda 2x squared y prime minus 2y prime equals negative 2xy squared minus 4x. And then I would greatest common factor y prime, 2x squared y minus 2y okay, so you get that. Sigamos acá. Ahora I would take that dividing over to the other side, and I get y prime equals negative 2xy squared minus 4x over, and that parentheses 2x squared y minus 2y. So that's your general formula for your derivative. So let me show you the steps so you can finish this one up on your own. Here we are. Okay, so you get, no, this needs to go first. Oh, so you can see it here in the back. So in the next step you need to do, you need to substitute the point, which was negative square root of 2 over 2, and positive square root of 2 over 2 and positive square root of 2 over 2 in x and y. It's right there. And when you're done with that, you're going to get the slope of the tangent line. Once you have the slope of the tangent line, you're not done, because here they want the equation of the tangent line. So how do you find the equation of a tangent line? You got two choices. I personally prefer using y equals mx plus b. Plugging in your slope for m and your point for x and y, solving for b, and then writing the equation y equals mx plus b. That's the way I personally prefer in the book, and some teachers prefer doing y minus y1 equals mx minus x1, the equation to write. And then plug in your point for x1 and y1, your derivative for m, and then solving for y. Okay, so try either, and then you should go ahead and do that, and you should get y equals 3x minus square root of 2, and if you can't get that, send me a message. Okay, that's it for